Okay, so now let's take a look at the result. Okay, so the first one is a residue, right? The residue is minimum is minus 4,600 about, and the median is about the max is about 3,700. So that's a residue. By the way, the residue. So what is the definition of the residue? Okay, where is it? Yeah. So this is a residue, right? So this is error, right? Error term, right? So error term is something. This is something that you observed, right, from your sample data, right? And this is what? This is the value from your linear model. So you calculate your linear model, right? So this is the value that you predict. So this is a predicted value, and this is something that you observed, right? So observed value minus a value from this model, right? So this is a predicted value. So the hat means the predicted value for y. So remember, whenever you have a hat, that means the predicted value, meaning that from this equation. Okay, having said that, right? So when you run this, you know that it's what? Let's see. Yeah, first let's talk about the residue. So the mean is the 4,653. So what that means is our models, so this model, right, over predicted the number of bikes rentals by how many? By 4,600, right? So this is like a over, right? So your model, right? Your model is what? Right. It's over predicted, right? So the reason that you got minus, remember the equations, right? So you got minus, right? So you remember equation is what? Residue. Ith residue is what? Something that you observed minus, right? Something that the value from your model this is predicted. And let's say, since this is a negative, right? Negative 4,600 roughly, right? It's a negative 4,600 or 4,600. So that means your model, right? It's over predicted, and that's why you got negative, right? And this is the actual value that you observe from your sample. And since your model Since your model, right? Since your model is over predicted, so this value is really big, and that's why you got negative, right? Okay, so and then the positive, same thing, right? Okay, so it's now for the positive case is what? Under predicted. So for this is the max, right? So this is for the what? Under predicted. So that's why you have a positive. Okay. So let's see. Let's just keep reading about the residue. So now we can look at the median residue to get a sense of the typical model performance, right? And now they say the median residue is about minus 100, right? So this is like a median value. So that means at least half of the residuals are negative. In other words, predicted value are more than the observed in about, it's more than 50% of the cases, right? So this is negative. So overall, right, 50% of your sample data, right? From your sample data, when you calculate the predicted value, about 50% of your data, right? For about 50% of your data, your models is what? Over predicted, right? So that you can make the inference. Okay, so that's about the residue, right? Now the coefficients, it's for the intercept is negative 166, and then temperature is a 78. So that's a slope, right? So from this, we know that it's what? We know that this is what? Y hat, right? Is the intercept is minus 166, and then plus the beta naught is 78, right? So 78, right? And multiply by x, right? So this x being temperature. and this y hat being rentals, right? Number of rentals. Okay, so that's about the coefficients. And then now they give the standard error, and then and then the t-value. So this is t-value is for the intercept. Okay, by the way, usually intercept we don't really care too much. Okay, so for the analysis we don't really look at the intercept, right? So what is important is the slope. So the most important thing is what? The p-value. Okay, so in this case is p-value is extremely small. Okay, so what does that mean? So what does it mean? Your p-value is really small. Okay, so now since the p-value is really small, it means what? It means the temperature features has a significance code of 3 stars, which means that it has a significance level between 0 and 0.001. The lower the significance level, right? So this lower the p-value is, the more predicted power the feature has, right? More predictive power a feature has. In practice, any feature with a significance level of 0.05 or less is statistically significant and it is good candidate for a model. Okay, so that means, so since this is a p-value, right? So remember when you watch this video tutorial, right? Maybe not this one, but the previous one. I'm talking about the hypothesis testing and p-value, right? So so this is basically the p-value, right? The small p-value, so means you know that you have a null hypothesis, right? You have a null hypothesis, H naught, and then you have alternative hypothesis, right? So your null hypothesis basically saying that, hey, there's no relation between the temperature, and there's no correlation whatsoever. So that means your beta 1, the slope is 0, right? Basically. And then even the intercept, basically if the slope is 0, that means there is no correlation between these two variables, right? However, the null hypothesis, the alternative hypothesis is what? By the way, yes, there is some correlation, right? So basically, it's not equal to 0, right? So that's the alternative hypothesis. When the p-value is this small, right? That means what? That means this is really close to 0. That means this is a strong evidence against the null hypothesis, right? So reject null hypothesis and take the alternative hypothesis, right? So that means there is a relation. There is correlation between the temperature and rentals. So temperature is definitely affect the number of rentals, right? Okay, so since we'll take the alternative hypothesis when the p-value is really small. And by the way, and usually the significance code, right? So anything, if your p-value is between 0 and 0.001 or the less, then you have really 3 star, right? And then usually the significance level, level is 0.05, the 5%, right? So if you look at this p-value, and if your p-value has a 3 star or the 2 star, the 2 star means your p-value is between 0.001 and 0.001, right? Between this, right? Then it's 2 star. The reason that we have a 3 star is basically it's really small value, right? It's really close to 0, and that's why it has 3 values. And then when you have a 1 star, that means less than 0.05. It's still significant, right? Still, this observation is statistically significant because the significant level is usually 5%, right? So when you see the 3 stars, 2 stars, or even 1 star, right? That means we can reject the null hypothesis and take the alternative hypothesis, right? In other words, your models, right? Your model is really relatively is a good fit, right? It's it relatively describe the describe the populations. Okay. So this is good. Okay, so this is good. However, when you see you don't really have any star, right? Maybe, dot or it's nothing, that means you cannot, right? You have failed to reject null hypothesis. That means the beta 1, the slope is a 0, right? Thus, we fail to reject the null hypothesis and your model, right? So we cannot use the model, right? We have to, yeah. So that means there is no correlation between the temperature and rentals, right? Okay, so that's what it means, right? And now let's take a look at the residue. So the p-value is very important here, the p-value, especially the p-value for the slope. So this is something that you have to really, examine first, basically. Okay? So so this is very important, this p-value. Oops, I like to use the red. Right? 3 means this, right? Anywhere between 0 and 0.001. Okay, and now let's look at the residue standard error. So 1509, and this is a degree of freedom, okay, 729, right? So what that means is your residue, right? Your residue, the standard error is about 1500, right? So what that means is, so let's see. Yeah, so what that means is, yeah, it's a predicted. Okay, so the actual number of bike rental deviate. So this is standard error, right? Deviates from our predicted by average of 1509 rentals. So on average, right, when you calculate your predicted rental, right, on average you have this this much error, right? And so yes, of course, the smaller this value is better, but this really depends on the context, right? Okay, so this number could be a really big one, or this number could be a really small one, because it depends on the context. Okay, so the RSC, right? This RSC value is measure of the lack of fit for a model. So whether this value is good or bad is dependent upon the context of the problem, right? In general, the smaller RSC, the better, right? And then they're talking about degree of freedom is 729 because if you look at your observation, I mean, there are 331 samples, okay? However, you have a two variable, right? So, you have a two, basically the variable, in this case is a temperature and then y-intercept, right? Two features actually, right? So you need to -2, right? So this is slope, right? And then intercept. So your degree of freedom is 729, right? As you can see, it's 729, right? Oops. So 700, where is it? Okay, 700, so this is degree of freedom. Now, let's look at the multiple r squared. It's simply just r squared, right? So you have r squared and adjusted r squared, right? And I believe, right? I mean, I'm sure that you watched this video tutorial, right? And then probably you learned this from your from your previous statistical, from your statistics course, right? But once again, if you, I mean, I'm already asked you to watch this video tutorial, right? So where is it? Yeah, especially especially this one, the degree of freedom. They're talking about this. If you look at this basic part 2, this author is well explains about the difference between adjusted r squared, right? So briefly, right? I wish there's no ad, but I think to watch this, I have to really. Okay, so I'm just looking at this. Okay, so if you look at this author, I mean, this author really well explained the concept of r squared and then adjusted r squared, right? So briefly, right? So briefly, let me this r squares. You know that when you add this number of independent variables, right? Let's say this time you only have a temperature, right? But last time, like we have a temperatures and some other what? You know, some other the variables like humidity, wind speed, and wind speed, and temperature, right? So as we increase this number of independent variables, we know that it's r squared, right? This r squared is, you see that it's simply increase, right? Whether your models, you know, gets better or not, simply when you, like in our case, we only have one independent variable, which is temperature, right? But later on, we can add more variables, right? Like humidity, wind speed, right? So when you add those two variables, like more and more variables, the problem with r squared is it blindly increased. You know that this r squared value is what? Increase, no matter what, right? However, when you look at the adjusted r squared, if your model does not really fit well, you know that you see the big difference, right? Your r squared, your adjusted r squared values even decrease significantly. Okay, so I mean, especially when you have a very small number of observations compared to large number of observation, right? So what it means is, so this is something that you should use. I mean, you don't have to really know the mathematical details about the adjusted r squared, but at least you need to understand how you should interpret this result, right? So when you have, let's say you have 6 independent variables, right? And then let's say you want to get a better model, and then you increase one more independent variable, right? You're adding one more, hoping that your models, gets better. However, as you can see, your adjusted r squared value is decreased significantly. So that means what? The one that you added, right? It's really like, it's not a good idea. It's a bad idea. Right? Your models basically get screwed. So maybe it's better to using a model with, like, for example, 6 variable. Okay, so then why this is important? So I mean, why you use adjusted r squared? I mean, when you use the adjusted r squared, when. So for example, you compare these two models, right? Then maybe it's a good idea to use adjusted r squared, right? And for example, let's look at this example. So you add additional variable, independent variable, and you know that your adjusted r squared is increase, right? You compare these two, right? So it's good, right? So it's increased. So yes, maybe it's a good idea to add one more variable, one more independent variable, right? And but in this case, right, it's not a really good idea because your adjusted r squared values decrease significantly. So it's not a good idea to add one more variable. Okay, so that's why adjust r squared is typically used to compare any two models, right? So so that's why I think it's let's see. Yeah, r squared statistics measure the proportion of the variability in the response variable that is explained by the regression model, right? Right. So okay, hold on. You know what? Okay, so that's like first. So that's a r squared. There's difference between r squared and adjusted r squares. I assume that you already watched this video tutorial, but anyway. So now go back to our example, right? So our result, right? Okay, our result is what? Our result is this. Where is it? Yeah. So this is r squared. R squared value is 0.3937, right? So that means 39%, right? we can say that our simple regression model explained the 39.3% of the variability in our data set. Okay? So we can, so using our model, right? This temperature, right? So 1 unit change in the temperature, right? You know that there is what? There is how much changes? Let's see. There's coefficient. Yeah, there's about 78 rentals, right? They'll be increase, right? So 1 unit of temperature increase, there's what? 78 rental increase, right? Output, but it only explains about 39% of your output, right? 78 rentals. Then what about the 60%? Okay, so let's say this is about 40%, right? It's a 40%. Then what about the 60%? Okay, so our model only can explain the 40% of these outputs, right? But what about the 60%? The 60% could be something like due to the humidity, right? It could be due to the wind speed, right? It could be something else. Maybe it could be some other unknown, right? Some other unknown factors, right? Could affect 60% of the outputs. But for our model, since our model is very simple, it has only one temperature, right? So read the temperature. It can only explain about 40% of the outputs. Okay, the change in the variability, like changes in your like in rentals. Okay, the 60% is due to something else other than the temperature. Okay, so now now the adjusted R square, right? So this R square is slight modification to the multiple R squared. In that it penalized the model with a large number of independent variables. So it is useful when comparing the performance. So they're talking about the comparing, right? And you're talking about adjusted R square, right? I already explained to you, right? Comparing, remember? Comparing, right? So that's a keyword. Comparing these two, for example, right? So you add more independent variables, right? Okay, so it's comparing, right, the performance of the several models with a different number of predictors. So predictors means the X variable, like independent variable. Okay, so the R squares are typically used. So they say in those scenario means as you add more and more independent variables, right? So let's say you add, at this time we only have a temperature, but later on we add, let's say, humidity, we add wind speed. So we add those more and more variables. So in those scenario, we used adjusted R squared instead of this multiple R squared. I'll just simply use R squared when evaluating how much the data is explained by each model, right? So that's it. Now the last thing is F statistics, right? So the F value is what? 473. So, but this F value does not really tell you much about this model, right? So what you have to really examine in this last row is p value. Okay, so as you can see, this p value is very small, right? So this p value is very small. So what that means is, let's see, okay? So the p value in F statistics, right? So this is the key here, right? So the p value takes the characteristic of the data set into account and tells how likely it is that the variables in our regression model fit the data in a statistically significant manner, right? So in our cases, the variables in our regression model is only like a temperature and rental, right? But But the closer this value is to 0, right? So the smaller the p-value is, basically, the better the fit, right? So our model better fit the model. So in our case, it's really, really small, right? It's like a e to the negative 16. So 2.2 multiplied by 10 to the what? Negative 16, right? So this is pretty much is close to 0. So that means our model, right? It's really fit the data, right? So our model is really overall. So the f value, okay. So the idea is f value tells you the overall, model, right? Like performance of the overall model, right? So this is f statistic is overall, right? And for this one, this p-value is really tells the individual variables, right? So later on, when you talk about the multiple linear regressions, right? This will, show. Let's say if you have a 3 independent variable, then it will show the p-value for each independent variable, right? But f statistic really shows the overall performance of your model, right? How your model really can fit the data, okay? And in our case, yes, it's really close to 0, right? And it's better fit, but usually as long as it's less than 0.05, right? Which is a 5% significance level, right? If it's less than 5%, then we can consider that your model is it's really good, a model, right? It's a really good one. And then yes, it's really fit the data, okay? So this is typically used by, the mathematicians and stat people, right? 0.05, it's very popular significance level, 5%. Okay, so that's about it. That's about this is something that you should able to interpret. Although in this class, I'm not going to ask you to really find this value by calculating all these equations. Your main goal is as long as you can interpret this result, right? Then I think you are in the good shape. Okay, thank you.